question is about polynomials in S4. All right, so you can first look at the basic hints first. X plus 1 is a factor of fx, implies that f negative 1 equals to 0, right? When fx is divided by negative 2, the remainder is 9. This implies that f2 is 9. All right, so basically, if you have two equations, two unknowns, you can use simultaneous equation with two unknowns to solve A and B. This will be simple, all right? So part A, f negative 1 equals to 0. So f negative 1 equals to negative 4 times negative 1 to the power 3 plus a plus 2 times negative 1 squared to negative 1 minus 3b equals to 0, all right? So when you use the calculator, 4 plus a plus 2 minus 2 minus 3b equals to 0, all right? A minus 3b is equal to negative 4. All right, so the first equation is formed, all right? And for the second equation, function f negative 1, f2 is 9. f2 equals 9. f2 equals to negative 4 times 2 cubed plus a plus 2 times 2 squared plus 2 times 2 minus 3b equals to 9. All right, so for the first part, negative 32 plus 4a plus 8 plus 4 minus 3b equals to 9. 4a minus 3b equals to 9 minus 4 minus 8 plus 32 equals to 29. So the second equation is formed, okay? Two unknowns, two equations. You can use simultaneous equation in two unknowns. Use the calculator program that you have to calculate the values of A and B, all right? So you can automatically calculate by solving 1 and 2. A equals to, it will be 11 and B equals to 5, okay? Use the program you have in the calculator for solving simultaneous equation, okay? So let's look at part B. Part B, at gx, let gx be the quotient when fx is divided by negative x squared plus 2x plus 3. And then someone claims that the equation kx times gx equals to fx has more than one real root, okay? So do you remember the division algorithm? The division algorithm, right? The division algorithm, gx be the quotient. So basically, fx divided by, so let's interpret the statement first. Fx divided by this one equals to gx. This is the quotient, right? So you can actually formulate that fx equals to gx times negative x squared plus 2x plus 3, okay? But first, let's look at what is fx first, because after you have obtained the values of a and b, you can calculate, you can find fx. Fx equals to negative 4x cubed plus 2 is a is 11 plus 2 times x squared plus 2x minus 3 times 5. Fx is basically this minus 15. All right. So you can basically use long division to find gx, because you can, after you know fx, you know this one, then you can use using long division, okay? So the long division here, I will do it here by using long division. Negative 4x cubed plus 13x squared plus 2x minus 15 divided by negative x squared plus 2x plus 3. So this one, this part, the first part will be 4. So that 4 times negative x squared is negative 4x cubed plus 8x. Oh, all right. 4x. Yes, 4x. 4x cubed plus 8x squared plus 12x. So you can calculate 5x squared to minus 12. It should be negative 10x minus 15, right? And then it should be minus 5. So negative x squared times negative 5 will be 5x squared minus 10x minus 15. All right, this will be the solution. Okay, so Therefore, as the quotient, this one equals to gx, right? So gx is equal to 4x minus 5. Okay, so you can, after basic solve, then we can look at the claim by that people. So someone claims that the equation kx gx equals to fx has more than one real root for all real values of k. Okay, so let's see. Kx times gx, which will be kx times 4x minus 5 equals to fx. Where is fx? Fx is this one, right? Negative 4x cubed plus 13x squared plus 2x minus 15. Oh, but do you remember, you can actually use the division algorithm that this one is also fx, right? So you can actually basically see that it should be equal to negative x squared plus 2x plus 3 times 4x minus 5. Okay, so this will be more easier because you can see, you can compare. We have 4x plus minus 5 here, 4x minus 5 here, right? Okay, so then you can actually eliminate it, right? No, you cannot eliminate it, because if you eliminate it, you are assuming that this is not 0, okay? So you cannot eliminate it. Instead, you need to factorize it. How? So let's see. Okay, it should be like moving all things into one side, minus equals to 0. Then we can factorize by picking the common factor, 4x minus 5, okay? 4x minus 5, kx plus x squared minus 2x minus 3 equals to 0, all right? So then you can calculate 4x minus 5, x squared plus k minus 2x minus 3 equals to 0. Okay, so you can solve the quadratic, you can solve the equation. This one, 4x minus 5 is equal to 0. So x will be equal to 5 over 4. Okay, this is one of the possible solution. And secondly, alternatively, this one equals to 0. Then, okay, so how can we do it? How do we know how many roots are there? When you see some unknowns, actually you can consider using delta. Delta can tell you how many roots are there, how many roots or distinct real roots. Okay, so let's see what happens first. Okay, delta equals to b squared minus 4ac, right? So k squared minus 4k plus 4 plus 12. So k squared minus 4k plus 16. So can you tell us whether delta is positive or negative? Actually, no. But how can we do so? We can actually use the method of completing the square. Or actually, we don't need to use method of completing the square. You can just like here. It's just like k minus 2 squared plus 12, okay? Because anything squared must be a positive value. A positive value plus a positive value must be a positive value, which must be larger than 0. So we can arrive to the conclusion that the equation of x squared plus k minus 2x minus 3 equals to 0 has two distinct real roots. Okay, there are two distinct real roots. Okay, so you can actually arrive to a conclusion that therefore the equation kxgx equals to fx has more than one real root for all real values of k. So at last the claim is agreed, okay? Okay, I believe that many of you would have probably missed some score because you directly eliminated this, all right? But actually you need to consider this kind of situation, okay? And arrive to two cases, considering two cases, okay? This is something we are testing for in this question, okay? So this is the end for question 11.